Hello, hello. This is the 14th webinar for Year 10, and the topic is simultaneous equations. So this is assignment 6, and today I will be focusing on harder problems. Okay, so I'm assuming you can do the easy ones. I'm doing the harder ones, and last year I did some more basic problems. So you can always watch last year's webinar on the same topic where I went through basic, more basic problems effectively. Right. Okay. So let's start. The first problem, we have a system. It's called a symmetric system because what does it mean symmetric? Because if you change x and y, if you change them round, it's the same system, right? If you rewrite it, and that means if xy is a solution, then yx is also a solution, right? So if I were to solve the problem and x is 2, y is 3, then x3 and y2 is also works because of the way the equations are formed. So symmetric if x, y, well, if let's not use x, y, if AB is a solution, then BA also a solution. A solution. Solution. And I've sent the link to the whiteboard in the chat. Right, so what can we do here? Well, in systems like this, you need to simultaneous equation and system is the same thing. Yes, so system means simultaneous equations. And in most of the world, we use a figure bracket like this. For some reason, in UK schools, they don't, but in UK universities, they definitely do. So I'm not sure why exactly they decided to get rid of the bracket, but it's very useful to have all the equations together. So here we use a substitution. Substitution is, let's say u is x plus y, and v is xy. Right. And that means you can have the first equation becomes u plus v equals 11. Now, the second one doesn't look like it can be written in terms of u and v, but actually it can. Note that x plus y squared is x squared plus 2xy plus y squared. And that means that x squared plus y squared can be written as x plus y squared minus 2xy, which is in turn is u squared minus 2v. Right? So u squared minus 2v plus v equals 19. So u plus v is 11. U squared minus v is 19. And you can, adding the two equations, adding the first and second, we get u squared plus u equals 30. Yes, 30. Or u squared plus u minus 30 equals 0. You can factorize this, I think. U plus 6, u minus 5 equals 0. So U1 is -6, U2 is 5. And of course, U plus V is 11. So V1 is V1 is 11 minus U. So 11 minus U, that is 17. And V2 is 5. V2 is 6. Okay. So we have U is -6 and V is 17, or V is U is 5 and V is 6. Let me double check. So the 17 feels a little bit awkward. Let me just double check quickly. 17 or 6. Okay. No, that's fine. -6. Okay. Now, if and we just rewrite that. U is x plus y. So x plus y is -6. Xy is 17. And here we have x plus y is 5 and xy is 6. Now, from here, it's very easy to guess from the first one. So that is 2, 3 and or 3, 2. Because 2 plus 3 is 5 and 3 and 3, well, 3 plus 2 is also 5. 2 times 3 is 6 and 3 times 2 is 6. Okay, so these are the two solutions. Now for this one, let's see, x plus y is -6 and xy is 17. So it looks like both x and y have to be negative. Well, what I'm going to do is I'm going to write y is equal to -6 minus x. So I substitute that in. Substitute, so x multiplied by -6 minus x equals 17 into 2. And this is -6x minus x squared equals 17. X squared plus 6x plus 17 equals 0. And I can either find the discriminant. So find the discriminant, and it's b squared, 6 squared minus 4 times 17. And also it's 36 minus 98. Really? 4 times? No. No, no, no. It's not 98, of course. 78. Therefore, sorry. 68. 68. And that's negative. So no real solutions. Solutions. Or I can say completing the square. Complete square. And this is x squared plus 6x plus 9 plus 8 equals 0. And you have x plus 3 squared plus 8 equals 0. And that's impossible. Why is that impossible? Well, because x plus 3 squared is a non-negative number, and 8 is a positive number. So it is not possible. And that means no real solutions. Because x plus 3 squared plus 8 is always positive. Right, so coming back to this, yeah. Now, one thing you might ask me, okay, I guessed two solutions, 2, 3, and 3, 2. How do I know that there are no more solutions? Well, easy, because if I substitute the first equation into the second, I get a quadratic equation, and a quadratic equation can only have up to two solutions. Hope that makes sense. So yeah, so x, if you sub, and the answer is 2, 3, and 3, 2. 2, 3, and 3, 2. Next one. Substitution with a change of variables. It's a very similar one. So I'm going to go u is xy and v. So let u is xy and v is x over y. Doesn't really matter which way I do it. X over y. So the first equation becomes u minus v equals 6. And the second equation becomes u minus 1 over v, because if x over y is v, then y over x is 1 over v, is 5. Okay, well, one thing I can say that v is not 1 from here, because if v was 1, then the two equations would be both equal to, I don't know, 6, for example. Okay, so what can I do here? I can multiply second equation by v. So from here, I write v equals u minus 6. And I multiply the second equation by v, so I get uv minus 1 equals 5v. And I substitute that in into the second one. So I get u multiplied by u minus 6 minus 1 equals 5 u minus 6. And now it's a quadratic equation. U squared minus 6u minus 1 equals 5u minus 30. U squared minus 11u plus 29 equals 0. Um, okay, well, I'm tempted to do completing the square or just use the quadratic formula. I'll use completing the square just for fun. Y minus 11 over 2 squared minus 121 over 4 plus 29. 29, which is 426 over 4 equals 0. So u minus 11 over 2 is equal to square plus or minus square root of 5 over 4, which is plus minus square root of 5 over 2. So u is 11 plus minus root 5 over 2. This is u. Okay. And, well, v. So if u1 is 11 plus root 5 over 2, then v1 is v is u minus 6. So 11 minus root 5 plus root 5 over 2 minus 6, which is 11 plus root 5 minus 12 over 2, which is minus 1 plus root 5 over 2. And u U2 is 11 minus root 5 over 2, and V2 is going to be 11 minus root 5 over 2 minus 6 equals minus 1 minus root 5 over 2, right? So we found U and V, but we haven't found X and Y yet. So what we do next is we do XY. So from here, XY is U. Yes. XY is 11 plus root 5 over 2, and X over Y is minus 1 plus root 5 over 2. And if we multiply the two equations together, we get x squared equals 11 plus root 5 multiplied by minus 1 plus root 5 over 4. And you can simplify that. You can simplify that and find x. So, and once you found x, you can find y as well. So hopefully that makes sense. Okay, well, let me do this. Let me do it for one of them, but not for the other. I think it just takes a lot of time. So minus 11 plus 11 root 5 minus root 5 plus 5 over 4. And also I don't want to make embarrassing mistakes. And minus root 6 plus 10 root 5 over 4, which is negative 3 plus 5 root 5 over 2. So that's x squared, and x is obviously the square root of that. So x is plus or minus square root of minus 3 plus 5 over 2. And y is going to be 11 plus root 5 over 2 divided by x plus minus root of minus 3 plus 5 root 5 over 2. Okay, simplifying that is sort of an arduous task, but it's doable. You have and you have two solutions. You have two solutions. Which you can explicitly find, right? So I'll leave it this to you, x and y. So here they are. And for the second one, so xy is 11 minus root 5 over 2, and x over y is minus 1 minus root 5 over 2. And if you multiply them together, you get xy times x over y. Xy multiplied by x over y is 11 minus root 5 over 2 multiplied by minus 1 minus root 5 over 2. And y cancels, so x squared is negative 11 root 5 plus root 5 and plus 5 over 4. And that is a negative 6, negative 10 root 11 over 4, which is a negative number. And so that's not possible because x squared cannot be a negative number. Possible, no real roots. Okay. No questions? How well did you understand the last question? On a scale of 0 to 10, please. I know it's not the easiest. It's probably one of the hardest problems today. Well, I mean, it's not that hard. It's just the simplification is really hard. Um, okay. Well, we can ask. This actually can be simplified, but yeah, you can get the solutions here. Right. I'll get some exciting problems coming up. Um, no one? All right. All right. Number three is relatively easy. Number three is a type of question you could easily find in your GCSEs. So right, you have two equations. One is a quadratic, one is a linear one. So all you need to do is to substitute one into the other. So from 2, you get x is 2y plus 1, and you sub into 1 into the first equation. So this is obviously the first equation, the second. You get x squared, so 2y plus 1 squared, minus 3x, 3, 2y plus 1, multiplied by y, plus 2y squared equals 4. Open the brackets. 4y squared plus 4y plus 1 minus 6y squared minus 3y plus 2y squared equals 4. Oh, what a lovely coincidence. 4y minus 3y, that's just y, equals 3. Wow, that's nice. So y is 3, and then x is 6 plus 1 equals 7. So 7, 3. This is the answer. Is it? Let's double check. Yep, 7, 3. Lovely. Okay, the next one. Next problem is another symmetrical one. You have, once again, it's a symmetrical system because changing x and y round doesn't change the system. It's the same system. And therefore, if AB is a solution, then BA is also a solution. Then we can note that x plus y cubed can be written as x cubed. Well, it's the same as x plus y multiplied by x plus y squared, which is x plus y multiplied by x squared plus 2xy plus y squared. And if you open the brackets, so that's going to be x cubed plus 2x squared y plus xy squared plus yx squared plus 2xy squared plus y cubed. And this is x cubed plus 3x squared y plus 3xy squared plus y cubed. This is a very important identity. So I recommend you memorize it, or at least get familiar with it. And therefore, x cubed plus y cubed can be expressed as x plus y cubed minus 3x squared y minus 3xy squared, which is x plus y cubed minus 3xy, x plus y, and you can sub, but x plus y is 5. Therefore, x cubed plus y cubed is 5 cubed minus 3xy multiplied by 5, which is 125 minus 15xy. So the equations become, the two simultaneous equations become 125 minus 15xy equals 35, and x plus y equals 5. Or in other words, x 15xy is 90. Yep, 90. And x plus y is 5. Divide by 15. So xy is 6 and x plus y is 5. And I've already explained why this is a quadratic equation, because if we substitute the second into the first, we will get a quadratic equation. And a quadratic equation can have only two roots. And if you can guess the two roots, that's enough. It's enough to say, oh, did I have 3 Q&As? Have I messed it up? 29. Dylan, thank you. Right. The Miro link is already in the chat. I'll place it again, because you might have joined later. That's why. The Pulley webinar on YouTube. I was sure I already have. I'll double check that. The webinar on YouTube. 29. Yes, I definitely have made a mistake. That's why. That's one of the reasons I didn't want to do this question, because 116. Oh, I've made two mistakes. 116, and then when you move that, it's going to be -5. So yeah, I've made two mistakes, and the two mistakes canceled each other out. Okay, wow. I'm very, very lucky today. Okay. Yes, so this is a quadratic equation. Once again, if I substitute one into the other, I get a quadratic, and I know already that 2, 3, and 3, 2 are solutions. So the answer is 2, 3, and 3, 2. Full stop. Lovely. Tangency condition. I'll explain why tangency in a minute, but find all values of A such that the system has exactly one solution. There's exactly one solution. So what I need to do is I literally substitute 2 into 1. So 2 into 1. And I get x squared plus ax minus 4 squared equals 25. So x squared plus a squared x squared minus 8ax plus 16 equals 25. So I get 1 plus a squared, 1 plus a squared x squared minus 8ax minus 9 equals 0. Has exactly one solution. So it has exactly one solution. There are two possibilities. Exactly one solution. If the discriminant b squared minus 4ac is 0, or, which you should never forget, the leading coefficient is 0. 1 plus a squared is 0. That means it's not a quadratic. Right? Because if the equation is not quadratic, the rule about discriminant doesn't apply. So you always have to consider the situation where the equation stops being a quadratic. That means the leading coefficient is 0. So you need to consider that. But that's not possible because 1 plus a squared is always positive. 1 plus a squared is always greater than 0. So no, not possible. Not possible. So we consider the first part. So discriminant. Discriminant is b squared minus 4ac. Sometimes discriminant is written as delta. So delta, this is just a different way of writing d. Discriminant is b squared minus 4ac. So that is minus 8a squared minus 4 multiplied by 1 plus a squared times negative 9. And that is 64a squared minus plus 36 plus 36a squared, which is 100a squared plus 36. And that discriminant is not 0, is not equal to 0, because 100a squared plus 36 is always positive. So the answer, there's no such values. And why is it called a tangency? Well, tangency because this is a curve and this is a straight line. This is a curve and this is straight line. So the only situation where a curve and a straight line have one point is when the straight line is a tangent to the curve. And we can draw that, ax minus 4. So Desmos, x squared plus y squared equals 25. That's the curve. Well, that's a circle, in fact. And the other one is y equals ax minus 4. Ax minus 4. And this is a straight line. And by changing a, I'm changing the gradient of that straight line. And you can see that as I change the gradient, there's no way to make only one point of intersection. It will always have 2 points of intersection. If it was minus 9, for example, then you could find such a value. You could find such a value that it has exactly one point of intersection. But it's not. It's -4. And that's why, and also geometric interpretation, it's a really nice one, because this is a circle, circle, and this is a straight line. So the circle has radius 5. So 5 minus 5. And the straight line with intercept -4. -4 is the intercept. And no matter how you draw the straight line, it will always have 2 points of intersection. So discriminant is always positive. That's what it means. Any such line will cross twice. Right. Apologies, I just need to step out for a few seconds. Okay, I'm back. All right, so this is called a system with a parameter, and the A is the parameter. Next one. These are my favorite ones. Like, really, really nice. There's two similar questions. I'm going to do both, hopefully. Oh, where's problem 7? Oh, here it is. Okay. Number 6, system with absolute values. So absolute values, if you remember, and I think I've mentioned, the definition, modulus x is x if x is positive, and it's minus x if x is negative. That's the definition of the modulus function. Therefore, first, I would consider case x minus y is positive. Or in other words, x greater or equal y. So if x greater or equal y, then the system becomes x minus y equals 3, and x squared plus y squared equals 25. And you know what? We can actually solve this equation. Can we? No, I don't think so. I don't think we can. We can't guess the solutions. I wanted to. We'll have to substitute. So we get y equals x minus 3 and x squared plus x minus 3 squared equals 25. X squared plus x squared minus 6x plus 9 equals 25. 2x squared minus 6x minus 16 equals 0. X squared minus 3x minus 8 equals 0. I believe there are there's no beautiful solutions to that one. Yeah, so we'll have to deal with it. X is equal to 3 plus square root. B squared is 9 plus 32 over 2. So that is 3 plus square root of 41 over 2. Or x is equal to 3 minus square root of 41 over 2. And therefore y is x minus 3. So that's 3 plus root 41 over 2 minus 3, which is minus 3 plus root 41 over 2. Or y is 3 minus root 41 over 2 minus 3, which is minus 3 minus root 41 over 2. And now check that x is greater or equal to y. And for the first one, it's very obviously yes. So yes, tick. And it is greater. You can see that it is greater than that. And this is obviously greater than that because 3 is greater than negative 3. So yes, that is true. So both solutions are suitable. Now, case 2. X minus y is less than 0. Therefore, x is less than y. And in that case, x minus y, sorry, minus x plus y is 3. And x squared plus y squared is 25. Okay. That's not, I don't think that's possible. Wait a second. How could it be? How could it be? Pause. Right. Um, okay. Well, we'll substitute that in. So that is y is x plus 3, and you have x squared plus x plus 3 squared equals 25. And that means x squared plus x squared plus 6x plus 9 equals 25. 2x squared plus 6x minus 16 equals 0. X squared plus 3x minus 8 equals 0. So x is minus 3 plus minus 3 minus root 41. Let's start with the plus over 2, or x is minus 3 minus root 41 over 2. Then y is x plus 3. So that is 3 plus root 41 over 2. Or y equals 3 minus root 41 over 2. And in both cases, you check that x less than y, and in both cases, x is less than y. So both are acceptable. So the answer answer. Right. So it's going to be there are four solutions. So 3 plus root 41 over 2 and minus 3 plus root 41 over 2. There is 3 minus root 41 over 2 and minus 3 minus root 41 over 2. There is minus 3 plus root 41 over 2 and 3 plus root 41 over 2. And finally, it's minus 3 minus root 41 over 2 and 3 minus root 41 over 2. You could potentially group them together and say plus minus at places, but I wouldn't because there's a big chance of getting it. Okay. Now I really want to do the next one. It's quite similar. Now you kind of have two moduli. And we know that they're different from the definition of modulus. So modulus 2x plus 3y could equal 2x plus 3y if 2x plus 3y is positive, or it's minus 2x minus 3y if 2x plus 3y is negative. And therefore, we have four combinations. This system is equivalent to this is the equivalence symbol. It's equivalent to four systems of equations. 2x plus 3y equals 5, and 2x minus 3y equals 1. And in this case, 2x plus 3y must be positive, and 2x minus 3y must be positive. Okay. Or it is 2x plus 3y equals 5, and minus 2x plus 3y equals 1. And this is when 2x plus 3y is positive and 2x minus 3y is negative. All right. So I'm not going to solve these inequalities. I'm just going to test the solutions because a system of linear equations can only have two solutions. One solution. All I need to do is to test that solution against the conditions. If that makes sense. And therefore, this one is minus 2x minus 3y equals 5, and 2x minus 3y equals 1. This is when 2x plus 3y is negative and 2x minus 3y is positive. And finally, I've got 2x plus minus 2x minus 3y equals 5, and minus 2x plus 3y equals 1. This is the case where they're both negative. 2x plus 3y is negative, and 2x minus 3y negative. If, 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 if. Okay, and this is OR. And all I need to do is to solve the simultaneous equations. And I'm going to do it by adding. So 4x is 6, so x is 3 over 2. And y, subtracting them, so 6y is 4. 6y is 4, so 2/3. Y is 2/3. This one, I'm adding the 2, so 6y is 6, so y is 1. And subtracting, so 4x is 4, so x is 1. For the third system, you're adding them together. So -6 is, so y is -1. And x is -4, so x is 1. Have I made a mistake somewhere? 4, 4, no. -4, 4, -4. Yeah, -1. Okay. And the last one, adding them together, that's -4. -4x is 6. -4x is 6, so x is -3 over 2. And y is, I think, is going to be 2/3 because of symmetry, but let's double check. 6y is -4, so -2/3, yes. And all we need to do is to test those solutions against the conditions. Or another option is just to test the solutions against the original equations. But I'm gonna go the hard way a little bit. So, does this solution fit this? Yes, it does. 2x plus 3y is obviously positive. 2x minus 3y, 2x, 2x is 3, and 3y is 2. That's suitable. Yes. So 3 over 2 and 2/3 is a solution. Right? X1 and y. So 2 plus 3 is positive, yes. 2 minus 3 is negative, also true. So 1, 1 is a solution. -1 and -1. So -1, -1. So that fits. -1. So -2 plus 3 is positive. So that's so -1 and -1 is also a solution. And I'm guessing the fourth one is also going to be a solution. Right, so x is -3 over 2, y is -3, so this is negative, of course. 2 times x, that's -3, plus 2, -3 plus 2 is negative, so that is true. So -3 over 2 and -2/3 is also a solution. Okay, and yeah, and you can also check that with Desmos. So modulus 2x plus 3y equals 5, and 2x minus 3y equals 1. And you can see it has 4 solutions. What happened? Did it not like it? Okay, has 4 solutions. Okay, lovely. Okay, the next one, um, I did not have enough time to go through this one, so I'm going to go a little bit on the fly with this, and it's quite a sophisticated one. So please bear in mind I can mess it up very badly. Hopefully I won't. Okay, so I only got to half of it on my piece of paper, but I'm I know where I was going. Okay, so this question. So what we can do is we can note that x plus y plus z, if you square this expression, so if you square the left-hand side of the first equation, you will get x squared plus y squared plus z squared plus 2 open bracket xy plus yz plus xz. Please do double check if you don't believe me, but it's a very nice thing to do. And then you can test your values because this is 6 squared. This is 14. And this is 2 times 11. So that's 36, which is 14 plus 22, which is true. So this tells us that the system is compatible. System is compatible. That means it has a solution. It has solutions. That's good. So we are on the right track. So now let's make some substitutions. Let S1 be x plus y plus z. S2 is xy plus yz plus xz. And S3 is xyz. Okay. Now we know that S1 is 6 and this is 11 and this is we don't know. No, no. But oh, right. Now, if you expand Vieta's theorem to cubic equations, remember Vieta's theorem. X squared plus bx plus c equals 0. Then x1 multiplied by x2 is okay, ax squared is minus, sorry, it's c over a, and x1 plus x2 is minus b over a. But you can also do Vieta's theorem for cubics. If you have ax cubed plus bx squared plus cx plus d equals 0, then x1 multiplied by x2 multiplied by x3 is still d over a minus d over a. Is it? Just a second. X minus x minus x2 minus x3. Yeah, minus d over a. x1, x2 plus x x2, x3 plus x1, x2 apologies. Um, yeah, okay. So that's just C over A. And x1 plus x2 plus x3, that is simply minus B over A. Minus B over A. Unfortunately, I don't have time to prove this, but you can prove it, prove by expanding A multiplied by x minus x1, x minus x2, and x minus x3 equals 0. Okay, nice. So we've got this Vieta's theorem, and note that if x, y, and z uh, so what it means here, that if um, just a second, S1, yes, if so x, y, and z, x, y, and z are solutions to the cubic equation where um, where minus b over a is x plus y plus z. You say so a t cubed plus b t squared plus ct plus d equals 0, where b over a is this, and that means that b is minus a multiplied by x plus y plus z. And that is x plus y plus z is 6, so minus 6a. C over a is xy plus yz plus xz, and that means that c is a multiplied by xy plus yz plus zx, and that is 11a. And finally, d minus d over a is xyz, which means that d is minus a xyz, which is unknown, xyz. And we can write down this equation. We can write the equation a t cubed plus b, which is minus 6a t squared, plus 11a t minus a xyz equals 0. We can cancel the a's, and we get a cubic equation t cubed minus 6t squared plus 11t minus xyz equals 0. Okay. Well, but we know that this is just S3. Okay. The equation. This is just xyz is just S3. S3, which we don't know. Right. And this is a cubic equation, so all we need is to find the S3 effectively. Okay, so we can try to find an integer solution, an integer solution. So just try t equals 1, and we get 1 minus 6 plus 11 minus S3 equals 0. And we have 12, 6, S3 is 6. Okay, and then t for S3 is 6. So then t equals 1 is a root. And we have xyz. Xyz is 6. And we get a cubic equation becomes t cubed minus 6t squared plus 11t minus 6 equals 0. And we can factorize. I know you haven't done factorization of cubics yet, but we can factorize that because we know that t minus 1 is a solution. T equals 1 is a solution. Therefore, we can do t cubed minus t squared minus 5t squared plus 5t plus 6t minus 6. And now we can group these. So all I did is I've written, instead of 6t squared minus 6t squared, I've written minus t minus 5t squared. And instead of 11t, I wrote 5t plus 6t. And now I can factorize it by grouping. So t squared, t minus 1, minus 5t, t minus 1, plus 6, t minus 1. It can factor out t minus 1. So don't worry if you're not following completely what I'm doing. It is sort of advanced stuff. And then t equals 1, t equals 2, and t equals 3. So these are the solutions. And we get 1, 2, and 3. So x plus y so effectively, because x plus y plus yeah, so x, y, and z are solutions to the cubic equation. So we have 3 solutions. So we have t1, t1, 2, and 3. And that means that the solutions are, so the answer is 1, 2, 1, 2, 3, 1, 3, 2, 2, 1, 3, and x, y. So these are the possible values of x, y, and z. And because the system is symmetrical, then all combinations are possible. All combinations. Nations are possible. Well, and there are 6 of them. So 2, 3, 1, 2, 3, 1, and 3, 1, 2, and 3, 2, 1. Potentially, yeah, potentially you could do it without a cubic. I haven't thought of another way of doing it, so try to. So we're trying to guess a solution, right? Now, question 8. 2 solutions. So this is a text problem. I love these. 2 solutions contain 20% and 40% salt respectively. So I always prefer to draw that. So the first solution, solution 1, contains 20% salt. 20% salt. And solution 2 contains 50% salt. I can't imagine anything containing 50% salt, but what are you going to do? Assuming it's water. So if it's 20% salt, imagine that this is total X kilograms, and this is total Y kilograms. If it's X kilograms, that means it's 0.2x kilograms of salt and 0.8x kilograms of water. And this one contains 0.5 Y kilograms of salt and 0.5 Y kilograms of water. Right. Now we mix them together. We mix them together and we get 0.2 0.2x plus 0.5 y of salt and 0.8x plus 0.5 y of water. Now, if 5 kilograms of water is added to their mixture, the result is 36. If 5 kilo is the result is 30% salt. So case 1, supply 5 kilograms of water. We get 0.2x plus 0.5 y of salt and 0.8x plus 0.5 y plus 5 of water, or we get 0.2x plus 0.5 y. So this is 5 kilograms of 40% salt. We get 0.2x plus 0.5 y plus 5 times 8. So that's 40%. So that's 2 kilograms of salt. If it's 5 kilograms of 40% solution, so there's 2 kilograms of salt and 3 kilograms of water. So 0.8x plus 0.5 y plus 3 kilograms of water. And the result is 30%. And here the result is 36%. And from here, we can write out. So what does it mean, 30%? Well, 30%, it means salt divided by salt plus water is 30%, right? So salt divided by salt plus water is 30%. That's what it means. So therefore, I can write salt, which is 0.2x plus 0.5y divided by their total. So x plus y plus 5. Oh, yes, 0 that's why 5 is 0.3. And here, 0.2x plus 0.5y plus 2 divided by x plus y plus 5. Oh, okay, that's convenient, is 0.36. And this is our system. Finally, it's so satisfying when it comes down to just that. So 0.2x plus 0.5y equals 0.3x plus 0.3y plus 0.3, so 0.15. And here we get 0.2x plus 0.5y equals 0.36x plus 0.36y plus 0.36 times 5. Is that 0.18? 1.8. Oh, oh, it's 1.5. 1.5. 1.8. Okay, and now we just solve that. 0.1x minus 0.1x plus 0.2y was 1.5. And here we get minus 0.16x plus 0.14y equals 1.8. Multiply everything by the first one by minus x plus 2y. Minus x plus 2y is 15. Minus a bit different. Yeah, I'll multiply it by 100. Minus 10x plus 20y equals 15. 150. And minus 16x plus 14y equals 180. It's just not nice. Okay, I multiply this by 8, multiply this by 5, and I get negative 80x plus 160y equals 150 times 8 times 8, 1200, and times 5 minus 80x plus 70y equals 180 times 5. Is it 900? 900. So subtracting the 2, so I get 90y equals 300, and that's y equals 300 divided by 9, 100 over 3, and if you subtract, if you do 70y, so x is 7,000 divided by 3 minus 900. So 900. So 70 times answer minus 900 divided by 80. To x is 215 over 12. So this is approximately 33.3, and this is approximately 17.9. 17.9. So these are the original values, the original amounts of the. Oh, I think you're right. 10 thirds. 300. Yes, 10 thirds. Of course, 700 by 3. But then the x value doesn't make sense. Okay, let me check. And 29. I think I've made a mistake somewhere. I must have. 0.2. Let's check the equation, the original equation. 0.2 plus 0.5 plus 2 is 0.36, and the first one is 0.2 plus 0.5, a 0.3. Yeah, that's not wrong. They multiply everything by 2. 0.16 minus. Oh, I missed the 2 here. Of course. Plus 2. And then this is minus 0.2. Minus 0.2. Okay, and then that is minus 20 minus 100 minus 100. So that's 1,100. 1,100. Wait, 1,100 divided. Still off. 0.16. Oh, plus. Why plus? Of course, because it's plus. All right. Plus. And 130 over 9. No, it's minus. Oh, of course. Yes, it is. Sorry. Um, Yes, so this is minus. This is minus. This is minus. And because I'm subtracting, this is 1,300. 1300, and that is not 10 over 3. That's 130 over 9. 130 over 9. And this is 130 over 9, which is approximately 14.4 kilograms. And x is, of course, x is 70 times 130 over 9 minus plus 100 all over 80, and that is 125 over 9, which is approximately 13.9 kilograms. Yes, that's the amount. That's the original amounts of the mixtures being used. Okay, I will leave you here. Hopefully that was useful to you. Hopefully not too overwhelming. I hope you enjoyed particularly the modulus ones, which are definitely my favorite, but also the substitutions. And I'll see you in 2 weeks' time, I believe. So that is on the next session is on the 23rd. So that is 2 weeks, right? So I'll see you. I'll see you and enjoy solving the the sheet.